Hey everyone, this is Professor Chan for Math 1245. Today we're going to continue on with section 2.6 with composite functions. So in this video I'm going to show you how to do composite functions in terms of doing the actual mathematical components of actual functions as opposed to values. And in the next video, I'm going to talk about domains for composite functions. Okay, this video right here is probably the basis and probably the bulk of section 2.6. So this is probably the most important of the three. Now I'm going to be doing the same problems for this video and then for the next video for 2.6 part 3. So let's get started, right? So let's talk about finding f of g, okay? So the problem now states that we want to figure out f of g and the domain. I will get to that in a bit, okay, with the domain part. I'll talk about that in the third video. So let's talk about what f of g of x is for the actual functions, okay? So notice this time they're not asking us f of g of 7 or f of g of 8, right? There's no number, it's just f of g of x. So this is how we deal with that, okay? So if I'm being asked to find f of g of x, okay? So remember the flow chart, right? Is we were saying x goes to g of x, which then goes to f of x. Now this time I'm not replacing with a number, I'm replacing with x. So let's look at the following. Well, we know g of x, right? When I plug x in for g of x, we actually don't need to do anything. We actually have it right here. It goes to negative 2 over x. Okay? So, right, I'm now going to take my output and go to f of x. So now instead of saying f of x, I'm saying f of negative 2 of x. So let us stop here, right? So what am I saying, right? Remember, I plug x into g of x. My output, or my result, is negative 2 over x. And then what happens is, right, this new output becomes my new input, okay? So it's kind of the same chain reaction we have, right? Whatever you get as a result, you plug it in for your next function, okay? So we have to be a little bit careful. So every single time I see an x, I'm going to replace it with negative 2 over x. Okay, now caution, some of these problems are going to look a little odd, okay? And these types of problems can vary a lot in difficulty. Sometimes you're going to have some pretty easy ones, and sometimes later on you'll see very clearly they're going to be very difficult. So now instead of saying x plus 3, I'm saying negative 2 over x plus 3. Okay? Make sure what I'm going to do is I'm going to do the following. I'm going to make sure that they have the same fraction. So I'm going to do the following where I'm going to combine them. Now remember, in order to combine, they must have the same denominator. So I'm going to multiply top and bottom by x. Okay, so, and then it'll become 3x minus 2 over x. Okay, so let's talk about how we simplify this. Remember, this is the top part is my top fraction, and then this right here is my bottom fraction. So I'm going to do 1 divided by 3x minus 2 over x, and I'm going to flip this. And 1 times x, 3x minus 2, and then this will be my final answer right here. Okay, so let's do another example here. I'm going to give myself some room. Sorry about that. Okay. Apologies for that. Here we go. So let's say here, once again, we're being asked to find f of g of x, okay? So I have, let's say you're being asked f of g of x again. So same thing. We replace, right, we want to replace x with g of x. You don't need to have to do this flow chart. I'm just kind of doing a visualization of what's happening. So this will become g of x. So the nice thing is the first part is always exactly the same, square root of x minus 1. And then if I do f of x, f of g of x, this will be f of square root of x minus 1. Okay, so remember your output becomes your new input. So this will look like the following. So I replace x squared plus 1, right? Every single time I see an x, I replace it with square root of x minus 1. So my new f of x, which gets replaced by square root of x minus 1, looks like the following. Does everyone see that? So notice my x square now gets replaced by square root of x minus 1 square. Okay, so whatever your new input is, right, you replace x by that. Square root of x minus 1 square becomes x minus 1 plus 1, and that equals x, and that's my final answer. Okay, and so you'll see when you're doing when you're doing these composite functions, sometimes it can get really easy, sometimes it can get really difficult. It kind of goes all around. It kind of varies a lot in difficulty. Okay. Yeah. Okay. So let me do another example here. Oh, okay. Yeah, let's do the same one. And sometimes they may flip it around. So maybe they'll ask you like, what is g of f of x? Okay, so they're like, what is g of f of x? So you're gonna do the same thing where you replace x into f of x first. So f of x will be equal to x squared plus 1. And then I replace that into g of x. So this becomes g of x squared plus 1 is equal to square root of x squared plus 1 minus 1. Okay, so once again, my x gets replaced with whatever's inside my parentheses. This one's nice. This becomes square root of x squared, right? 1 minus 1 is cancels out, and then square root of x squared becomes x, okay? This problem here, which we'll get into later on, is called an inverse. Don't worry too much about that, but it's a special type of problem in section 2.7. Okay? Okay. So let's do a couple more, or let's do part C. Okay. So let's say once again, you're being asked f of g of x. Okay, so once again, look inside. Okay, yeah, and let me kind of clarify. So for some of you guys who kind of have problems like which one's first, you always see the one that's closer to x, okay? Regardless of whether you write it as f parentheses g of x or f middle circle of g of x, right? So we're always doing g in this case because it's the one closer to x, okay? Let me erase that. Okay. So I look inside first, and I notice g of x will be equal to 2 over x, okay? Now, what will f of x look like when I plug in 2 over x? This is where it gets a little tedious. F of 2 over x is equal to 2 over x over 2 over x plus 3. Okay, so as you can see, this gets a little dicey, okay, but again, the concept still holds up, right? We're replacing x with 2 over x. Okay, Now just make sure you know some of your basic math. Combine the bottom part of your fraction. So you're going to multiply the top and bottom here, sorry about that, by x over x. Okay. And continue on, and I'm combining the bottom portion. It's going to be 2 over x all over 3x plus 2 over x. You have a fraction over a fraction. This equals to 2 over x divided by 3x plus 2 over x. So you'll multiply by the reciprocal. Then the x's cancel. I'm left with 2 over 3x plus 2, and that is my final answer. Okay. So here's the thing, the concept, once again, concept should not be difficult. I think what will probably be, for some of you, what can be the difficult situation is just a lot of the math concepts. So making sure you know how to simplify mathematically, whether it be like factoring or multiplying fractions or adding fractions or knowing your square roots or your radicals. That's something that you need to be mindful about. Okay. Okay. And then let's just do one more. So I'm going to look at part E. Let's say we flip it around. Okay. And I'm doing, let's say we'll flip it around. I'm going to do g of f of x. So this is going to be f of x, right, is x squared plus 1. So my g, remember, will be replaced by 2x squared plus 3. So it's going to look like this. Okay. So again, think of it as like kind of like your outline. G is your outline, and you replace your x with x squared plus 1. Okay, distribute this. So this is x to the 4th plus 2x squared plus 1. Okay, make sure you know how to FOIL this correctly. Okay, if you don't understand that, feel free to send me an email. And this is 2x to the 4th plus 4x squared plus 2 plus 3. Right, I'm distributing my 2, and then I'm going to combine my like terms. And then that is your final answer right here. Okay. Okay. So as you can see, all like 4 problems that we did with composites, they all have very differing results. The concept's the same, but the execution is different, right? Some of them you may have to divide, some of them you have to multiply, and sometimes you may have to FOIL. Okay. Let's look at the following, okay? This is not as important compared to one we just did, but there are some problems you may run into where it says find f and g so that f of g is equal to h, okay? So the idea is I have this function such that I want to find 2 functions such that when I do the composite, it's going to be h, okay? So the idea is if I do f of g of x, right? So if I look at this problem here, if I do f of g of x, I want it so that it becomes 2x plus 3 to the fourth, okay? Now the trick is, okay, is generally your f of x is going to be the outside, your g of x is going to be the inside, or whichever is the one that's closer to x, that's going to be your inside part of your function. Your f of x is going to be, or the outside part is going to be your outside part of your function. So what do I mean by that? So let me give you the example. So I notice g of x, that's what I'm starting off. So I notice g of x is going to be the inside. And then my f of x will just be x to the fourth, okay? Because I'm looking at the outside portion of my new composite, okay? So when I do the composite of both of these, watch what happens. So I have f of g of x that equals, right, g of x is 2x plus 3. So that means I'm going to plug this in. So I have 2x plus 3, and then I replace x with 2x plus 3, and that is actually what we just get here. Okay. And that's it. Okay. Okay, so we're going to end here. This is going to be a section you want to practice, okay, a lot of. If you have questions, let me know. Okay. Yeah, so this is definitely the part that you want to practice a lot of and make sure you know how to kind of do the mathematical execution. Okay. But other than that, we'll continue on with the last part of 2.6, and I'll see you guys later.